Okay. You love quarantine life. You don't have to get ready for other people to see you or, anything else like that. Okay. Okay. Should I wait? Hey, Fiona. Hey, Drew. So we got 4 of you and Sungwoo. Okay. Okay. Should I just go on? You guys can open up the notes. We're gonna be starting at. I need to find a part of the solution. Okay. For some reason, the video is also delayed now. I don't know why. Maybe it's not. You're dying, Daniel? Daniel, it also might be suggestion. Wait, what? How much homework did I give you last time? Oh no, that was what I did homework. Homework 4. Let's see. Oh. Well, all you had to do was tell whether it was. Daniel, there's also a thing called procrastination, which I've learned is a terrible thing that will eat away at the very soul of an individual. But we did talk about it. Teachers did. Okay. Yeah. We talked about that. I try. You don't procrastinate these days? I'm impressed. Okay, we're gonna start on this. So normally this would be it would be both 10.6 and 10.7. Oh, it's not supposed to be hyperbolous. It's supposed to be parametric. Well, you guys can fix that on your own. Parametric equations. Okay. Our test for chapter 10 will, so we have this section, 10.7, 10.8. 10.7 would be Wednesday. It'll be a shorter assignment. Then we have 10.8 the week after that. So our test would be on Thursday or Friday next week. Which one would you prefer, Thursday or Friday? So write in chat whether you prefer Thursday or Friday next week for our test. I will be giving you back the homework here. Actually, today would be a great day to do it. Okay. Okay. We're gonna talk about some definitions. It would be a time range, so you have to take the test at a specific time unless you are unable to. So if someone's not able to, you can contact me, but I would assign a specific time of day. Okay? Okay, we're going to talk about a parameter. So parameter essentially means we're introducing, it's a third variable to guide our equation. In this case, it's time. Okay, so we're introducing time t. Okay, so parameter is a third variable that got to guide our equation. In this case, it's time t. So that's our that's what we're going to be dealing with is a third variable. Okay, so today's is all about the third variable. A parametric equation is when we write x and y as functions of t. Okay. Okay. Hi, Henry. I'm glad you could join. So the question is, test next week. Hey, Adi, and where are most of us who are here? The junior teacher did talk today. We're trying to make it reasonable for you guys, okay? I'm sorry if it's not yet. We'll try to fix it, okay? Okay, so an example of a parametric equation here would be x equals 24 square root 2t. Okay? And we would have a y equation. Sorry. Y equals -16 t squared plus 24 square root 2t. Okay? Okay, so this is sorry. It's not wanting to. Okay. These are our parametric equations. Okay, so they set up x and y as functions of t. Okay? So we're gonna have, when we do a table, it's gonna have all three our tables are gonna have three variables. In the book, it's not under the square root. Good question. It's not under the square root. So yeah, this looks confusing, but it's not under the square root. I don't know how to, yeah. Technically, if we want to be honest, it should be this, but I don't know, they both look bad. So we'll just ignore these equations because we're not going to deal with them anymore. Okay, and a plane curve is basically the resulting graph of our parametric. So that's the graph of our parametric. And it's continuous. By the way, Precalculus, we're going to skip chapter 11 because for the purpose of calculus, you don't need chapter 11 unless you're doing BC. And chapter 12 is just more important in general. Okay, plane curve. Here's our definition. If f and g are continuous functions of t on an interval I, well, this is much harder than I thought it would be. Okay. The set of all of ordered pairs f of t and g of t is a plane curve C. Okay, the equations are going to be this. X equals f of t and y equals g of t. Okay? Okay, these are parametric equations for C. And the t is the parameter. Okay? Any questions of this? This is just filling in the blank. I'll leave this up. And actually, can I freeze screen? Is there a way to freeze screen? That's something I need to learn. Sorry, guys. You know what? No, I can't freeze screen. Okay. Yeah, let's do that for your sake. My apologies. Let's just zoom in. Boom. Okay. Should work out. Guys, once it uploads. Okay. Make it easier for you guys to see. Okay. This is not like. Whatever. Okay, you guys got that? Okay, we're gonna move on. Okay, sketching a plane curve. First thing we need to know before we do a plane curve is orientation. All orientation means is it's tracing the increasing values of t. Tracing the increasing values of t. Okay? So it's tracing as we go, it's tracing the increasing values of t. I think that should be big enough. Even bigger. Okay. Tracing the increasing values of t. Okay, so it's as you graph. Can I type while zooming in? I can zoom in before, or I can zoom in after. I can't zoom in while I'm typing. I'm not that skilled. I think I have to hit Control Plus, and that's just too many buttons. So it's tracing the increasing values of t. Okay, we're gonna do some graphs over here. So I'm gonna zoom out of this and work on my board over here. Okay. So I'm on the next page. We're only 4 pages today. Hopefully it'll be 1 hour. Oh, that reminds me. I need to send a message real quick. So I'm gonna set this up and then I'll send my message. Okay. So our x function, t squared, sorry, let's get this here, t squared minus 4, our y function equals t over 2, and we have negative 2, t is less than 30, okay? So what we're going to do is actually we're going to make a table. We're going to have t, x, then y. Negative 2, negative 1, 0, 1, 2, 3. And all I'm going to do here is plug in these t values into these equations. So t is negative 2 into x. Negative 2 squared is 4. 4 minus 4 is 0. Negative 2 up here is just negative 1. Negative 1 here is going to give us 1. 1 minus 4 is 3. Negative 1 here is negative 1/2. 0 here is just going to be negative 4. Sorry, this should be negative 3. Negative 4, this should be 0. 1 should be negative 3. This should be 1/2. This should be 0 and 1. And this should be 5 and 3 over 2. Okay? So graphing this, we're going to plot it as t increases. Apologize, that line is not straight. Okay, there we go. Okay. I'm just going to do it by twos. 2, 4, 6. 2, 4, 6. 2, 4, 6. 2, 4, 6. 2, 4. Okay. So what we're going to start with is the first one. Okay, we're going to start at this point. 0, negative 1 right here. And then we're going to go to negative 3, negative 1/2, which should be right here. So we would plot it this way. Then we have negative 4, 0, which is right there. Then we have negative 3, 1/2, which is right here. Then we have 0, 1, which is right here. Then we have 5, 3 over 2, which is going to be, 3 over 2 is going to be just a little bit over, sorry, right there. Now you draw arrows to show which direction this function is going. Okay, the arrows are telling us it traces out. Okay, sorry. So we trace out these arrows to see where we're going. So we're going to try out a problem. I want you to do the same thing as this for the other question. Okay, same kind of process for the question with x equals the square root of t, and where it says y equals 3 minus t, and then it tells us make the table for 0, 1, 2, 3, 4, and plot the graph and sketch graph, okay? So I want you to do that right now. I'll give you a little bit of time to work on that, and then I'll come back to this screen with the answer, okay? Okay, so let's try. I still like this song. Okay, coming back. music. Okay, so we're gonna go into this problem. So let me make my table. Let's say this is 1, 1.5, 2, 1, 2, 3, -1. Okay, so we would start at the point 0, 3. So that would be up here. Then our graph would go to 1, x is 1, y is 2. And then we would go to 1.4, which 1.4 for x, and 1 for y. Oh, this makes less sense, but it's okay. Yeah, that didn't work out. Hold on 1 second. This should be bigger. Okay. Small, and this should be big, and this should be 2. Okay. Sorry, 1, 2, 3. So start here, go to here, go to 1.4. Okay, and then 1.7 and 0. So right about here. Then 2, -1 here. So if you graph this, sorry, this should be right there. That's just bad graph. Okay, and then you graph with the arrows. So your arrows tell you where it should be. Make sure the points are clear. That's basically the key. Okay, so you have arrows. If I was to make it bigger, it'd be you plot it. With parametric, you make the arrow in the middle, okay, of your graph. Okay, so these arrows to tell you what direction the t is going. Okay, so that's graphing. Okay, we don't have many pages on this homework assignment, thankfully. So hopefully that won't be too difficult. Okay, we're going to talk about eliminating parametric. Before we continue, does anyone have questions on graphing? Before we continue, does anyone have questions on graphing? So all we do with graphing is we plug our t in to our two functions. Okay? Sorry about that. Split the camera. Okay. Now we're going to talk about the steps of eliminating a parametric. Okay? Eliminating a parametric. Okay, first thing, we start with our parametric equations. An example of this would be x equals t squared minus 4 and y equals t divided by 2. Okay, start with our parametric. Then we're going to solve for the t in one equation. Okay, so example is we would get y 2y equals t. Okay, so we solve for the t in one of the equations. Next, we're going to substitute in other equation. Sorry about this. Okay, which means what you're going to do is you're going to get x equals 2y squared minus 4. Okay, you're going to plug in the 2y for t. And then last step is you get your rectangular equation. Which our rectangular equation in this case is x equals 4y squared minus 4. Okay? So, first step, you have your parametric equation. Then you're going to solve for the t in one of the equations. We choose the one that's simpler. You don't want to choose a complex one. Choose the simpler one. I'm going to plug it into our next equation, and then solve that equation. Okay? Okay? Now, if you're asking how to type this out quickly, don't worry. You don't have to type it out. I'll just show you how to do it another time, if anyone's interested. Okay, so we're going to sketch the curve represented by the equations by eliminating the parametric and adjusting the domain of the resulting rectangular equation. Okay, there's some specifics that will mean. Okay, this example will mean something more than this example. This example. So let's show you how to do that. Gotta switch my screen. Sorry. Okay, and let's just do this over here. Do this. Drag over here. And do this. Transition. Okay. So our first one's x. X equals 1 over square root of t plus 1, and y equals t over t plus 1. Now, which of these is easier to solve? The answer is the one with the square root. This other one has t on numerator and denominator, so it's really much easier to do this other one. Okay? So we first get the t out of the denominator, so multiply both sides for the square root. Before we do that, that's not the easiest step. Let's square both sides. We want to get rid of the square. Square both sides, we get x squared equals 1 over t plus 1. Okay, all we did was just square both sides. Then we're going to multiply by the denominator to both sides. Okay, get the t into the numerator. So this cancels out, so we get x squared times t plus 1. I'm going to make my t a little bit curved, equals 1. Okay, we're going to divide both sides by x squared, and we get t plus 1 equals 1 over x squared. Okay? After this is t plus 1 plus 1. We're going to subtract 1 from both sides. So we get t equals 1 over x squared minus 1. Now, this minus 1, we're going to get the same denominator, so minus x squared. So we'll get t equals 1 minus x squared over x squared. Okay? Now, all we're doing is going to plug this into this equation up here. Okay? So all this work, I'm just showing you the algebra, all the work here is getting us to this up here. Okay? So, how do we do it? Well, I'm going to show you. I'm just going to plug this in here. Okay? So I'm going to erase this. If you didn't get all of the work I just did, feel free to look back and at the video. Okay, so y will equal 1 minus x squared over 1 minus x squared plus 1, which, if you see this plus 1, that's just going to be the same thing. So we're going to get 1 minus x squared over x squared over x squared plus x squared, x squared. Okay, so the x squareds are going to cancel here and here. So we're going to get y equals 1 minus x squared, x squared. I'm going to just say divided by, because that's what this huge fraction means, 1 over x squared, which is the same thing. Dividing by this is the same thing as multiplying by the reciprocal. So we get 1 minus x squared over x squared times x squared over 1. These two cancel, so we're going to get 1 minus x squared. Y equals 1 minus x squared. Okay. Okay. Now this is a lot of work, and I know that. That's why this homework assignment is far shorter, because it makes sense. But this one, there's a restriction on the domain. And the restriction on the domain is this thing right here. Okay, this can't be less than 0. So t has to be greater than -1. Okay, so that is going to be our restriction, which means x has to be greater than or equal to 0. Okay? Okay, because you can't have less than 0. But really, actually, it can't be equal to. X has to just be greater than 0. Okay? Okay? So, that's the first problem. I want you to try the second problem. I'm going to give you a minute. I want you to write in the chat what the equation is. Okay? So, what is the equation of the second problem? Okay? So, what's the equation of this parameter? Okay? I'll give you like 3 minutes. Okay? How do you know that x for x and t? Okay, it is very loud. So guys, I'm going to try to talk. It's raining really hard. So we'll see, okay? Too loud, let me know. Okay. Now, I haven't graphed this one yet, but we'll graph it in a minute. Okay, so gonna graph this later, okay? Our one that I gave you was x equals 1/4 t, y equals t squared. Now it's easier just to solve the x equation, so we're just gonna multiply both sides by 4. We get 4x equals t. And we're going to just plug this in for t over here. Okay? So we get y equals 4t squared. Y equals 16t squared. Okay? So, we get this equation. Sorry. It should be x squared. Okay? So I'm going to show this graph, and then I'm going to show this graph. Okay? Okay, that's what this graph is going to look like because our domain is restricted. The one over here has no domain restrictions, so it's going to be honestly, it's going to go extremely fast. Okay. Okay. And then, so how do we know the restriction? You look at t, okay? You look at the original function, what can t not equal to is your question. So our second one doesn't have an issue. T can be anything because both our x and our y are functions that will be consistent. Okay. So we're going to go on to the next problem, and you can let me know if you have issue hearing me or issue seeing. We're going to eliminate angular parameter, okay? Now this is going to be not what you're used to, but it should make it straightforward. So I'm going to show you the first one, and then we're going to do the second one ourselves. Sorry, let me blow this up a little bit. So, angular, we're going to be talking about the first one over here, this one, okay, this one over here, and then you're going to do this one over here, okay? These two, okay? So the first rule with this is that we are going to be doing a circle equation. What does that mean? Well, we have, apologies real quick, reorganize this. X is going to equal 3 cosine of theta. Y is going to equal 4 sine of theta. Now, we have a rule. Okay? We have cosine squared of theta plus sine squared of theta equals 1. We're going to use this. Okay? Now, how do we use this? Well, we need to solve this so that cosine theta equals x divided by 3. Okay, do you see that? We divided both sides by 3. What do we do over here? Divide both sides by 4. So sine of theta equals y over 4. Okay, what are we going to do with these two? We're going to plug them here. So we're going to get x over 3 squared plus y over 4 squared equals 1. Well, x over 3 is x squared over 9 plus y squared over 16 equals 1. Okay? What is this equation right here? What kind of shape is that? Okay? In chat, what is it? Write it out. And how do you sketch this curve? I'm going to sketch the curve over here. Someone can guess the shape? I'll sketch the curve. What shape is this? What shape is it? This shape right here. An ellipse, yep. And our axis, our major axis is y, is 4. And our x, let's fix our graph a little bit. A wonky ellipse. Okay. Okay, it is an ellipse. Okay, still a little bit. Okay, there we go. That's much better. Comparatively speaking. Okay, so let's try the second one out. I'm going to erase this real quick. Now, the one thing we do know is what direction is this going? It's actually going this direction right here. Okay, it starts at this point right here and goes around. Now, how do you figure that out? You can make a table, okay? Okay, second question. X equals 6 sine 2 theta. Y equals 6 cosine of 2 theta. Now it's the same problem, same process we just used. You can really just set 2 theta to be equal to some u, and then it'll work out, okay? So if you set it to some u, this becomes easier, okay? So, first step, you need to rewrite these. So x equals 6 sine of u, and y equals 6 cosine of u. Okay, how do we set this up? Well, we need our sine. Sorry, something's going on. Oh, the stream just ended. Brilliant, David. Sorry, people. My computer just was stupid. Sorry, people. My computer just died. Okay. I'm back. Okay, I'm back. So sine of u is going to equal x over 6. And cosine of u is going to equal y over 6. So we plug these into sine squared u plus cosine squared u equals 1. So x over 6 squared plus y over 6 squared equals 1. I do not know what's the other. Sorry. Why computer sometimes? Put this over here. Okay. So this becomes x squared over 36 plus y squared over 36. If they're the same thing, you just multiply everything by 36. Get rid of the denominator, and you get x squared plus y squared equals 36. And that is your equation right here, which is a lovely circle. 1, 2, 4, 6. 4, 6, 2, 4, 6, 2, 4, 6. There we go. Okay? So, gives us a lovely circle. Yep? There's a circle. Okay? So, how do we eliminate the parametric? We follow the two possibilities. If it's an angle, we use our circle. If it is a sorry, I don't know why I just did that. If it's an angle, we use our circle equation. If it's t, we use our range to then simplify it. Okay. This transition. Okay. Now we're going to finding the parametric equations for a graph. Okay. So all we're doing in this last part, the arrow goes counterclockwise. Yeah. Good question. The arrow goes counterclockwise. in general. Okay? So we're gonna do one equation, so A and B are part of what we're gonna do. So we have our equation y equals 1 minus x squared. And basically, we're going to find the set of parametric equations for the rectangular equation given the parameter. Okay. So, here's our equation. They give us A is t equals x, and B is t equals 2 minus x. So, this first one, we're going to plug in x in here. We're going to plug t in for x. Okay, so we're going to get y equals 1 minus t squared. Y equals 1 minus t squared. And x equals t. So that's our set of parametric equations for A. For B, I'm going to change this so it's t minus 2 equals negative x. X equals 2 minus t. Okay? I'm just going to get y equals 1 minus 2 minus t squared. Y equals 1 minus 4 plus 4t minus t squared. So our answer is y equals negative t squared plus 4t minus 3, and x equals 2 minus t. So all we're doing is plugging in our t. We're going to plug it in the opposite way. So when we plugged in x before, we're going to plug in t and solve. Okay? So that is one of the last equations that you have to deal with. So there's 3 more problems. So our 3 more problems are, we have y equals to x squared minus 3, y equals 3x minus 2, and y equals 1 over 2x. Okay, choose one of these 3, and we have A, x equals t, and B, the opposite way, t equals x, and B, t equals 2 minus x. Okay? So, figure it out. Choose one of those 2 and solve. And we'll be done after you've solved that problem. So, let's put on some beautiful music. Put on some, you got rain, but Okay. Well, which question do you want me to do? The first one, the second one, or the third one? First, second, or third? Which one do you want me to do? First is x squared. Second is a linear equation. And third one is a different equation. Yeah, I got a vote for 2 and a vote for 1. Well, we'll do both 1 and 2 and not 3 because no one voted on 3. Feels bad, 3. You got kicked off the island. Okay, first one, we're just plugging t for the first part. So we get y equals t squared minus 3 and x equals t. Boom, done. That first part's easy. Second part, hard part. You got to set this up. So we have t equals 2 minus x, so then we need to get x equals 2 minus t. Okay, we'll plug this in. Y equals 2 minus t squared minus 3. So we get y equals 4 minus 4t plus t squared minus 3. So you get y equals 2 t squared minus 4t plus 1 and x equals 2 minus t. Get that rhythm in. Okay, that's the first one. The second one, just plug in that t, so you get y equals 2 3t minus 2 and x equals t. Okay, that's the first part. Second part, y equals 2 3, plug in 2 minus t in, because we've already solved this, minus 2. So you get y equals 6 minus 3t minus 2. Solving this, we will get y equals 2 negative 3t plus 4 and x equals 2 minus t. And we have solved it. So this is B, A, 1A, 1B. Sorry, don't know why I'm going that order. 1A, 1B, 2A, 2B. Okay, that's how we do those. I posted the homework. You guys have a wonderful, sorry, let me up the volume of this mic a little bit. Hey, you guys have a great day. Thank you guys for joining. I will try to make sure the next lecture is not too long or too hard, and that I give you a good set of notes for it, okay? Thank you guys for joining today. Have a wonderful rest of the day. You guys are awesome. Stay awesome during quarantine. Okay, bye.